All right, folks. I know that we weren't able to have class today, which is kind of a shame, but excuse me. But I wanted an opportunity to take the opportunity to record just some thoughts on the study guide. This is what we were going to take a look at in class today, and hopefully answer any kind of preemptive questions that might exist among you. If you have more questions after you watch this video, of course, you're welcome to send me an email. I'll try and respond as quickly as possible. And if your question is pertinent to the whole class, I will reply all to your email so that everybody gets a chance to see the answers to your questions. Okay, so let's take a look at the first one. We have a tile growth pattern. We have three things that we need to do. We need to draw the fourth figure. We need to make two equations where your figure number is x and the number of small triangles is y, and then you need to explain how you can see one of the equations you made. So when I look at these growth patterns, generally speaking, the first thing I do is look at the largest one, because by the time the largest one has come along, you can generally start to see what the pattern is doing. Hopefully you can see that there's something like basically a central triangle here, which has 9 little triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these triangles, every time you add a layer, like you can see I did it on lined paper. So, and I would recommend when you're drawing your figure 4 that you also draw lines to keep everything straight. But anyways, every time you add a line, it's like basically doing that number of levels squared. So like one line is 1 squared, 2 lines is 4, right? 3 lines is 9, and so on. Okay, so that's going to be the connection to quadratics. You've got your central triangle with 9, and then each time you're adding basically like one triangle on each side, minus the little cutoffs here. There's 3 ones that have overlap, so those ones don't count. So you can think about each of these triangles is like an x squared. So when we go down to our equations, we have a 3x squared, and then in addition to these x squared triangles, we also have the 2 extra ones, and you can see there's like 2 here, 2 here, and 2 here. And so that makes sense that we would have 3x squared plus 6. Okay, now the other one, 3 times x squared plus 2, you can think about as, okay, let's say that we have this triangle here, and then it has its counterpoints up here, right? This triangle here has its counterpoints over here, and this triangle up here, it has its counterpoints down and to the right. You can also see this on the other figure numbers, right? We have a smaller triangle here, a triangle with 4 small triangles inside of it, and it has the 2 over here, right? Same with this one up in the upper left-hand corner with the 2 triangles on the lower right, and so on. Okay, so hopefully those 2 equations make sense in the context of the situation. Again, when you're trying to figure out the equation, generally speaking, it makes the most sense to look at the largest figure number and see how the various parts of it relate to the figure number. Okay. When drawing figure 4, this is fairly challenging. I mean, it's not like just drawing a bunch of boxes. You have to be a little bit neater. There are no horizontal lines here, but I would recommend when you're drawing yours, you might consider drawing a set of horizontal lines corresponding to how many levels there will have to be. If you look at the figure 3, you know that it's going to have to be one taller up here and one taller on the bottom as well. So we're going to need to have 1, 2, 3, 4, 5, 6, 7, 8 levels. And you can see there's 1, 2, 3, 4, 5, 6, 7, 8 levels here. So you can do that. The other thing is it might make sense to draw the little triangle first, right? And then expand out with the 3 larger triangles. The figure that I drew for the test will not be quite as complex as this one, but it will require that you draw reasonably accurately. Okay, lastly, our answer, the first equation, y equals 3x squared plus 6, can be seen in the 3 triangles that grow by a row each time, like an x squared box, and then the 6 extra triangles that stick out each time. And I pointed to them up here. We have the 3x squared triangles, and then we have the 6 extra ones that are circled. Okay, all right, we're going to move on. Okay, when graphing this equation, what are some things that I did first? Well, first of all, I noticed that we had a 1.5 here, and I know that this is a standard form equation, so I can just immediately put in our y-intercept of 0, 1.5. All right, I also, let's see, what else did I do? I also factored this, so I factored out a negative 0.5. Now, when we factor out a negative 0.5, we multiply what each of the coefficients was by negative 2, so it becomes x squared plus 2x because it was minus x up here, and then minus 3 since it was plus 1.5. So we have x squared plus 2x minus 3. That's a pretty easily factorable standard form equation. It factors into x minus 1, x plus 3. You can draw the box if you want, but my hope is that after having done enough of these that you can kind of see that minus 3 has only two factors, plus 3 minus 1 and minus 3 plus 1, and so we need to make it so that we have a plus 2x here, so it's x plus 3 down here. Okay, this tells us our x-intercepts at 1 and negative 3, which are plotted here, 1, 0, negative 3, 0. From there, we can get our line of symmetry, which is at x equals 2, or excuse me, x equals negative 1, my mistake. When we plug in negative 1, we can find our vertex just by solving, basically. Negative 0.5 times 1, because negative 1 parentheses squared is 1. Minus minus is plus, and plus 1.5. We have negative 0.5 plus 2.5 is equal to 2, so our vertex is up at negative 1, 2. That's really all you need to do. You'll notice that I also did the a value one over here, but you could also think about it as a symmetrical reflection across the line of symmetry. Okay, so that's basically all you have to do. Make sure that you label all of your points to get full credit, but otherwise that's pretty straightforward. Okay, we're gonna move on. Let's see. No, that's the third page. Okay, so we're going to talk about making a graph from the equation. So first of all, when you see this graph, I think that the easiest way to go about this is to take a look at the x-intercepts and start making a factored form equation out of that. Now, there are an infinite number of parabolas that can go through these two x-intercepts based on having different a values, right? You could have this one be much steeper. It could go like kind of like this, or it could be shallower. It could go like this. But either way, what you want to do is make sure that you are not just saying that the equation is x plus 5 times x minus 3, but rather taking the time to figure out what the a value is. This is only one extra step. All you have to do is plug in a point that's not the x-intercepts. There's an obvious one here at 0, negative 5, so plug that point in. So we have negative 5 goes into the y value, 0 goes into the x values, and then we solve for a, which is like an unknown. So we have ultimately 5 times negative 3 times a is equal to negative 5. We multiply those two together and divide by negative 15 so that we end up with negative 5 over negative 15 equals 1/3. So our a value is 1/3. So I wrote it over here, y equals 1/3 x plus 5 x minus 3. I also wrote it in the factored form up here. Okay, so we've got this factored form equation. This is a good stepping stone to make our standard form equation. I just FOILed this out. You can use box method too if you want. You could insert the 1/3 into the x plus 5. Remember not to insert the 1/3 into both the x plus 5 and the x minus 3. That's not correct. You only multiply, since they're all being multiplied together, you can just multiply them by these two terms. So 1/3 times x, 1/3 times 5, so 1/3 x plus 5/3, parentheses times x minus 3. Or you can just multiply by 1/3 at the end, which is what I did. So we end up with 1/3 x squared plus 2/3 x minus 5. Okay, this also makes sense because minus 5 we see as our y-intercept, and that is our y-intercept, so that's good. Okay. Lastly, from the factored form equation, we can figure out what the line of symmetry is. The line of symmetry here being at x equals negative 1. Now, I actually didn't do any calculations to get the y value of the vertex. All I did was I said, okay, well, I know that the vertex is at x equals negative 1, and I know that based on our a value of 1/3, we go up 1/3 and over 1 to the right, which means that this the y value of the vertex has to be negative 5 and 1/3 because we went from 5 to go over 1 and down 1/3 would make it -5 1/3. So I can plug in -5 1/3 there. And that's all that you have to do for that one. Okay. Okay, so I used two different methods for this one because it makes more sense to do it for some than for others. For the first one, I noted that the x-intercepts were 1 and -2 based on our factored form equation, which tells us our line of symmetry is at -0.5. You could also do, if it were a standard form equation, you could do -b over 2a, although in this case I completed the square because it wasn't too difficult. Anyways, plug in -0.5 into our x to find what the y value of our vertex is. So we end up with 3 times -0.5 minus 1, -0.5 plus 2, so 3 times -1.5 times 1.5. One thing that you may have noticed by now is that when you have a factored form equation and you plug in the x value of the vertex, oftentimes the two parentheses will give you the same number. Like we have -1.5 and 1.5. I mean, ignore the negative for a moment. What that's basically telling you is that when you are multiplying two numbers together, generally the largest in absolute value, I mean, obviously this is the most negative, but it's still basically the largest, is a perfect square. This kind of is relevant to like what we talked about when we talked about area, as the largest rectangle given a certain perimeter is a square. So there's sort of a connection there that you might want to pay attention to. Okay, anyways, we solve, we get -6.75 as our y value of our vertex. So now we have our vertex, and we just want to make sure we keep an eye on that a value, which is 3, and plug that in down here. So we have 3 times x plus 0.5 squared minus 6.75. Okay, the next one, fairly straightforward. I pulled out a 1/2 x. I should have added a plus 3 over here. I just forgot to add it in this step, but it's okay because we have it down here. But anyways, pull out a 1/2 from the 1/2 x squared and the minus 6x, so we get 1/2 times parentheses x squared minus 12x. Complete the square. You can use the box, but I can do this in my head because you cut -12 in half to get -6. Square that to get 36. So we have 36 here. Because we added 36 here, we want to subtract 1/2 times 36 out here, which is 18. This x squared minus 12x plus 36 becomes 1, and then times 1/2 becomes 1/2 x minus 6 parentheses squared. And then on the outside, we have plus 3 minus 18. That becomes minus 15. Okay, over on here, I figured out what the factors were. So I factored out a 2x from both 2x squared and -6x to get 2x times parentheses x minus 3. So our factors are 0 and 3. So our line of symmetry is at 1.5. It's fairly straightforward. You could also do -b over 2a. You'd also get 1.5. Anyways, plug in 1.5 for both parts where we have an x. And solve for y. Our y value is -4.5, so our vertex is 1.5, -4.5. Again, remembering our a value is 2, so we bring down that 2, and then we have x minus 1.5, parentheses squared, minus 4.5. Okay, moving right along. Here is our second to last problem, where we have sorry, I should have come up a little bit. So if you launch a toy rocket into the air from ground level, its distance in feet from the ground in t seconds can be given by f of t is equal to -16t squared plus 208t. So that means that f of t is how high off the ground it is, and t is the distance in feet from the ground. So distance in feet from the ground is f of t, and t seconds is what the t represents. Okay. So what do the terms -16t squared and 208t represent? Well, if you think about this as a parabola, right, the positive term is basically the initial speed. It's the thing pushing the rocket up, whereas the -16t squared is the thing pushing it down. So all in all, that's pretty much all you got to say, right? -16t squared represents acceleration downward, right, because it's negative due to gravity. And 208t is the initial upward velocity, right? It's positive, so going up. I mean, the only other thing you might consider adding, you don't have to, but is the fact that the t squared, right, gets bigger over time, and the 208t also gets bigger, but not as much, because it's not squared. And so what happens is at first, right? The initial upward velocity from the rocket's fast speed is really large, but over time, the gravity, because it continues to act on the rocket at every point during its trajectory, takes over, and at some point, then it starts to fall back down to Earth, which makes sense, right? Because we observe that rockets do, in fact, fall back down to Earth if they're just launched up with no extra rocket fuel in them. Okay, then we draw a diagram. So we have a parabola. The parabola is denoted by f of t is the height on the y-axis in feet, and the x-axis is t time in seconds. At 0 seconds, it's at 0 feet. At 13 seconds, it's at 0 feet. Because you can factor this and figure it out. I wrote this in after I figured out what the factors were, which I have here. 16, negative 16 t and t minus 13. This part's not actually part of solving the number c. It's actually really part of figuring out that 13 is the other point, is when the rocket hits the ground, and also that 6.5 seconds is going to be the top because it's in between 0 and 13, and then plugging in 6.5 gives us our height of 676 feet at the peak. Okay. Lastly, solving for how many seconds have gone by when the rocket is 192 meters above the ground. That should be feet. This should be feet. That was stupid. I made a mistake here. Anyways, so what we do is we say, okay, well, when is our equation, negative 16t squared plus 208t, equal to 192? Well, okay, you can see that we can turn this into like a regular quadratic equation by subtracting 192 from both sides. Now, this may not be apparent to everyone, but probably the easiest way to figure out then what when this is true is to pull out a 16. Now, this should be negative, and for whatever reason, I did the things correctly of switching the signs, but there should be a negative here. Then we have t squared minus 13t plus 12. This is actually not as hard a problem as you'd think, because 12 can just be like 12 and 1, and we can see minus 12 minus 1 gives us 13. So when t equals 12 and t equals 1, the rocket will be 192 feet off the ground. And you can see I labeled that here and here. And it's not perfect. It maybe should be a little lower given that this is 676. So this should only be about a third of the way up, maybe over here. But you get the general idea. Okay. Lastly, okay, so for this one, we're really just describing things, and they need to be accurate descriptions in order to get full marks on this problem. One thing that I did before I started was I found the factored form equation, which allows me to say a few other things that the standard form won't let me say by itself. So 4x minus 5 times x plus 1 will give us this standard form equation, right? 4x squared plus 4x minus 5x. That's not right. 4x plus 4x should be, this should be minus 1x, not minus 4x. So we'll need to change something about this. Let's see, what is in fact the correct answer on this one? Probably it's 2x times, no. I need to think about this for a second. All right. Okay, folks, so we're back. So I made a mistake on the study guide. As you can see, we have 4x squared minus 4x plus 5 on Desmos. It's got a vertex at 0.5, 4. It's got a y-intercept at 5, and it has no x-intercepts because it starts above. Anyways, so we need to take a quick look back to see what is correct and what's incorrect. Okay, so first of all, this parabola has a y-intercept at 0, 5, which makes its min value is less than y equals 5. Which means its min value should be equal to y equals 5. I don't know why I said less than. That doesn't make any sense. Okay, it doesn't have any x-intercepts, so this part is incorrect. But its axis of symmetry, I think, is at 1/8. No, it's at 1/2. That's also wrong. I don't know why I said that. It should be at 1/2. Okay. And then since its a value is positive, it's decreasing from negative infinity to 0.5 and increasing from 0.5 to infinity, which shows that its domain is all real numbers. That's true, and it is increasing and decreasing on those things if you put 0.5 here instead of 0.18. Okay, so those are three things that are true about this. I don't know. I'll need to send an email out about that. Okay. Well, anyways, that's that last one. This one isn't too difficult as long as you're not stupid like me and get the wrong factored form equation. This one has no factored form equation, which is why you can't make a factored form equation. So that's wrong. Okay. Well, if you have any other questions, send me an email. Otherwise, I hope you have a wonderful and hopefully as healthy as possible and indoors weekend. Bye-bye.